Welcome back. This will be the last time that I'm lecturing for y'all this week, and we're just going to pick up where we left off, talking about the neural basis for cognition. So today that's going to look like briefly review the stuff we talked about this class period, because we're going to try to tie all that back into what we're talking about today. We're going to move on to looking at neurons specifically, how those are set up and how they play into how we think. And then we're going to start to look at the visual system as a specific example of where all these things that we've been talking about come together, so we can understand how the brain and how cognition and perception and behavior all relate to each other. So the first thing that I wanted to go back to was this thing that I was proposing to y'all that obviously is not exactly in the textbook, because I know it's not going to be on the exam, but I do think that it's important, so I'm going to try to present that case one more time to y'all. It's basically talking about that as we're moving around and looking at different parts of the brain and learning their kind of convoluted names, we want to be able to understand what those names actually mean, because they'll help us as we continue to learn about more and more different areas and try to keep track of all that. So there's this vocabulary that describes the different locations of the brain, which is like anterior versus posterior for front to back, superior and inferior for top and bottom, dorsal and ventral also for top and bottom, and lateral and medial for the sides or the middle, right? And then we can combine that with the names that we already know, the 4 different lobes of the cortex and the different wrinkled folds of the cortex. And if you understand what all of those are, then anytime you come across a new area of the brain with a really weird name, you'll know where it is, and that'll help guide you along. So, in general, if you're like reading a paper and they're talking about someone that has a certain psychological disorder where they have trouble producing speech, and they say that it's related to damage in the posterior frontal lobe, let's say, then you would understand, even if they don't say what caused exactly that speech dysfunction, you know that the posterior frontal lobe is where the motor cortex is. So you already know some function related to this area, so you can say that maybe that speech disorder is related to their ability to control their motor behaviors. And then also, it's basically, if you're learning about all these different areas of the brain and trying to remember where they are and what their names are, you're going to be memorizing just an infinite number of words and locations, and that is really inefficient, and we already do tricks and processes to get around things like this. So, for example, we have vocabulary to be able to navigate a map of the United States and understand where things are. So, like volunteer, preferably someone who doesn't travel much, and is not a geography nerd, or but maybe hasn't grown up exactly around here. Does anyone fit that would want to volunteer? Then I'll just loosen the criteria, any volunteer. Cool, convenient sample right here. So this is your tool. Top up there is the laser pointer. Yeah, so could you point to where NC State University is? Yeah, I think that's pretty spot on. How do you know that? Yeah, so you already knew where Raleigh was in the first place. Do you think that someone that lives in, say, you've been to Arizona? Where haven't you been? Oh, really? Okay. Let's try California. I said Arizona. My luck. So do you think someone that lives in California has never been here, do you think they would know where NC State University is? Where do you think they would point to if you told them? Just guess where NC State University is. Okay, well then you just guess. Yeah, probably so. Why do you think they would say that? Yeah, central location. You said it's a state university. Which state? Yeah. Yeah. So they wouldn't necessarily point somewhere down here, right? Yeah. So the state names in this case, in the analogy I'm using, is kind of like the different lobes that we have. So you've never been to California, and you point to University of California, Riverside. Try. You chose the center part of the state. Yeah. So what about, let's say we trim that down a little bit, what about Southern California University? Yeah, I think that's like pretty much spot on. Yeah, and so it's because we were able to define it in the name as Southern California, so south, north, west, east, those are kind of like the ventral, dorsal, things like that. So even if you have no knowledge about any of these things, if you know the name and the information is in the name, then you can find it. So you said UC Riverside was in California at least, that's pretty close, you're not over here. And it turns out UC Riverside is actually right next to USC right down there too, but it's not, that information isn't in the name. So it's the same kind of trick that you can use when you're navigating the brain. So we've memorized 50 state names, we know where those are, and we've memorized the compass, so we have these cardinal directions. And there's basically 4 of those, but that really trims down the amount of information that you have to memorize when you're thinking about where something is in the US or where something is in the brain. So that's the last thing I'll say about that. Think about it, and it'll tie into later, you'll probably talk about memory and chunking, so maybe try to keep that in mind. And then also, as we explore how neurons code things more, the same kind of concepts will come up. So it's basically combining pieces of information that you have and being able to use those in a bunch of different ways. Thank you.